Hello, this is Emily First from Kemin Crop Technologies, and today I'm going to talk to you about a new product for your consideration in IR-4 evaluations. Aster is an experimental product soil disinfectant. Its active ingredients include thyme, clove, garlic, and cinnamon oils. The mode of action is through FRAC BM01 or cell membrane disruption. It can be applied on all crops, both indoor and outdoor. Targeted pests include broad-spectrum fungal and bacterial soil-borne pathogens, weed seeds, and nematodes. The application rate is for 2 to 6 gallons per 100 gallons, with one application, but possibly two, intended for a pre-plant spray interval initial application, and then a second application could be either post-harvest or as needed. It is a FIFRA 25B product, so it's a 0 REI and a 0-day PHI. We conducted some soil assays looking at Iowa farm soil, which had a considerable amount of organic material. We looked at the bacterial count and the fungal count, as well as pathogens present such as Fusarium and Pythium. The soil was treated at 2%, 4%, or 6% aster, or with water as a negative control. So 15 grams of soil were applied with the treatment. It was incubated at 25 degrees and held for 48 hours. Following by then cereal full dilutions and being plated for the total counts. Here are the soil assay results looking at the total aerobic bacterial count as well as the fungal count. On the left axis we see the log colony forming units per gram of soil, and for each treatment you see on top of the bar there's also a percentage which represents the total percent knockdown of the population relative to that time 0 point. In both cases you can see with increasing concentrations of aster you see a decreasing count or population of either the bacteria or the fungi, with as much as 89.9% knockdown in the population of the bacterial aerobic count and a 99.9% knockdown in the fungal count. In both cases, you see anywhere between a log of 1 to 3 log knockdown, which is a significant reduction in the total populations. We see a similar trend in decreasing the Fusarium and Pythium populations with increasing aster concentration. Again, with as much as 77% knockdown of the Fusarium population compared to time 0 for 6% aster. And then also at 6% aster on the Pythium population, we see as much as 98.9% knockdown compared to the time 0 population. Overall, we were able to show that aster was effective at being able to reduce these two fungal populations. Here are some summary tables of the soil assays looking at either the bacterial, fungal, Fusarium, or Pythium populations, and we're looking at the percent knockdown compared to either the time 0 population or that negative control sample, which was treated with water and incubated for 48 hours. With either regards, we're looking at the increasing concentration of aster from 2 to 6% was able to significantly reduce the populations of these soil-borne microorganisms. We also conducted a weed seed trial in a greenhouse where we used a 488 tray that was cut into 3x2 mini cell trays. 6 of these mini trays were used for each treatment, and it was set up in a complete randomized block design. We looked at lamb's quarters, milkweed, ragweed, and slough grass. These seeds were sowed and then treated either with water as a negative control or aster at either 0.5, 1, 2, 4, or 6%. We also used a positive control, which was a glyphosate, imazapic, and diquat blend applied at a 6 fluid ounces per gallon. Treatments were applied once, and then the seeds were grown under irrigation 2 times a day and then evaluated frequently. Here you can see the results for each of the different weed seeds, the number of average seeds germinated on the respective days over a 26-day period. Overall, you can see that ragweed germinated the earliest, followed by lamb's quarters at the latest, almost 3 weeks in. As the rate of aster increased, we saw that the number of germination of seeds substantially was reduced. And as soon as you started hitting 2 to 4%, we started to see equivalent comparison to that positive control. So here's kind of a summary table of the weed seed trial results, looking at the percent control of the seed germination compared to the water treatment over that time period. And overall statistics were also compared for the treatments, looking at the 0.5% aster not really being any different than the water treatment. But however, once you start hitting at 1% aster, we start to see some separation. But really at 2%, we see some significant control, followed by 4 and 6%, again being statistically similar to that positive control for these different weed seeds. Aster is a soil disinfectant. It's a new experimental product that we would like to request some evaluation by IR-4. Should be applied 5 to 7 days prior to planting. It should be drenched into the soil for sufficient penetration into the soil to the desired depth. Preferably drip tape irrigation under plastic mulch is how we originally designed this product. However, it may also be amenable to spray irrigation, assuming that the rates can be appropriately applied. With the suggested rates at a minimal amount of 2 gallons per 100 gallons for mild pressure and maintenance, up to that 6 gallons per 100 gallons for known pressure and potential concerns. What we're requesting is for efficacy testing, which would be on all soil-borne plant pathogens, looking at weed seeds and nematodes in all crops. I'd like to thank you for your time and consideration today, and if you have any questions, please reach out to either myself, Emily First, or Michael Hull, our Technical Services Manager, and we can answer any of your questions and provide you any feedback that you need. Thank you.